Today, we're unpacking the completely fascinating and honestly hidden science behind something literally every single one of us does every day. I'm talking about a behavior you probably did this morning when you dragged yourself out of bed, and you'll for sure do it again before hitting the pillow tonight. But here's the crazy part. Despite how incredibly common it is, almost everyone completely misunderstands its true biological purpose. Actually, real quick before we get into the heavy science, consider this a fair warning. You're almost certainly going to yawn during this explainer. I mean, we're studying a deeply contagious phenomenon today. Even just hearing me talk about it is probably going to trigger that powerful urge. So if you feel a jaw stretch coming on, don't fight it. Just let it happen. Think of it as actively participating in the science we're breaking down right now. So what's the first thing that comes to mind when you think about why you yawn? If you're like most of us, you probably assume it's because you're exhausted, bored out of your skull, or maybe your body is desperately crying out for more oxygen. I mean, it makes intuitive sense, right? You take a massive deep breath, so obviously you must be trying to get more air into your lungs. Okay, let's dive into this. Because it turns out that old belief, the whole we yawn for oxygen or because we're sleepy thing, is totally wrong. It misses the mark entirely. The scientific reality is so much cooler. Decades of research show that yawns actually serve as a highly specialized brain cooling mechanism. And rather than just being a sign that you're tuning out, yawning frequently happens during moments of stress, anxiety, or intense anticipation. Basically, times when your brain activity is actually spiking, not powering down. Yeah, the whole myth tying yawning to our need for oxygen, that was actually dismantled way back in 1987. Dr. Robert Provine ran this landmark experiment where he brought people into a lab and messed with the exact mixture of air they were breathing. And guess what? Pumping in extra pure oxygen did absolutely nothing to stop people from yawning. On the flip side, jacking up the carbon dioxide didn't make them yawn more either. The definitive conclusion here is that yawning and regular breathing are controlled by totally separate physiological mechanisms. It literally has nothing to do with oxygen deprivation. Which brings us to Section 1, your brain's built-in radiator, how a simple jaw stretch acts like engine coolant. So if it's not about oxygen, what is the deal? Well, to get this, we kind of need to look at yawning on a micro level. A great way to think about it is like a car radiator. Just like a revved-up engine, your brain produces a ton of heat when it's working hard. And there are three main things dictating that temperature: the speed of blood traveling to your brain, the temperature of that blood, and the amount of heat the brain itself is turning out. Think about what makes you sweat on a sweltering summer day. It depends on how much breeze there is, how cool that breeze is, and whether you're running a marathon or just chilling on the porch. When your brain gets too hot from stress, or maybe sleep deprivation, or just heavy mental lifting, it needs a breeze. It needs to cool down. And this brilliantly illustrates the actual fluid mechanics happening inside your skull when you yawn. When you forcefully stretch your jaw open, that intense muscular pressure literally squeezes warm blood away from your head. You can see it here with the red arrows. It's almost like wringing out a hot, wet sponge. But right at the exact same time, that massive inhalation of ambient air cools the blood circulating down by your lungs, which then rushes right back up to refill the brain, shown by the blue arrows. You are manually flushing out hot fluid and pulling in cool fluid. Now, if that sounds like just a theory, let's look at the hard empirical data. Researchers actually put this to the test by placing these super precise thermal sensors right on the brains of lab rats. And looking at the data, they found a rapid spike in the rat's brain temperature in the exact minutes leading up to a yawn. That's the red peak you see here. Then immediately after the physical act of yawning, boom, the brain temperature rapidly dropped right back down to a baseline healthy level, shown in blue. The yawn is literally the biological thermostat kicking on so the brain doesn't overheat. All right, moving on to Section 2, the Goldilocks temperature zone, why the weather outside determines your yawns. Look, it's simple logic. You wouldn't jump into a steaming hot tub on a 100-degree summer day to cool off, right? That would be totally counterproductive, not to mention dangerous. In the exact same way, if the air temperature outside is warmer than your internal body temperature, taking a massive, gaping breath of that sweltering air isn't going to cool your brain down at all. It would actually heat it up even more. So biologically speaking, we should actually be yawning way less in extremely hot environments. Now, what's really interesting about this slide is how perfectly the real-world data lines up with that logic. This chart maps out yawning frequency against ambient air temperature. Notice that sweet spot in the middle? That is called the thermal neutral zone. When it's just slightly warm, when our brains need cooling but the air outside is still cooler than our blood, yawning absolutely peaks. But check out the extremes. When it's blistering hot out, yawning plummets, because other cooling systems like sweating have to take over. And in freezing cold weather, yawning drops again, because the brain just doesn't need any extra help staying chill. Next up, Section 3, Big brains, long yawns. How brain size dictates the length of a yawn. You see, this cooling mechanism isn't just some weird quirk of human biology. It's a deeply conserved evolutionary trait found all across birds and mammals. And get this, the size of the animal's brain directly correlates with how they yawn. We can anchor this in a super basic biological rule of thermodynamics. Larger things just take much, much longer to heat up and cool down compared to smaller things. Think about a massive, deep lake in the winter. It takes weeks of freezing temperatures for it to finally ice over. But an ice cube tray in your freezer, that takes maybe a couple of hours. The exact same physical principle applies to the biological mass of a brain. So researchers actually went out and observed all these diverse mammal species measuring the exact duration of their yawns. And the findings were mind-blowing. They discovered that larger brains need a much longer, more sustained radiator flush. And this is completely independent of the animal's overall body size. It's the exact weight of the brain and the total number of cortical neurons that dictate how long that yawn lasts. The more complex and dense the neural network, the longer the jaw stretch has to be to effectively flush out that heat. It's just a brilliantly conserved trait across vertebrate evolution. Let's move to and see how this builds into Section 4, the contagious yawning truth, from primitive reflex to social synchronization. So we've talked a ton about the internal, physiological mechanics of yawning, but we still kind of have to address the elephant in the room. Why on earth is it so incredibly contagious? I mean, why are you probably fighting the urge to yawn right this second? To answer that, we have to contrast spontaneous yawning with contagious yawning. Spontaneous yawning, yawning because your brain is hot, is ancient. It's universal across vertebrates. In humans, it actually starts in the womb before a baby even takes its first breath. But contagious yawning, that's a way more recent evolutionary development. It's only been documented in highly social species, and interestingly enough, it doesn't even develop in human babies until well after infancy. It is completely triggered by external social cues rather than internal brain heat. So the crucial point is that contagious yawning functions to synchronize and coordinate group activity patterns. It's essentially a biological survival tool for social groups. If a yawn is a physiological mechanism that wakes a brain up, transitioning it from rest to alert activity by cooling it down, then contagious yawning acts like a ripple effect through a community. Picture a flock of birds or a troop of chimps. If one member senses a shift in the environment, yawns to boost their alertness, and gets ready to move, the contagious spread of that yawn ensures the whole entire group syncs up their brain activity and moves together safely. It's honestly genius. And understanding all of this goes way beyond just, winning your local trivia night. It actually has profound real-world medical applications. Because yawning is a literal window into the brain's thermoregulation, medical professionals are really starting to see its diagnostic power. Patients dealing with conditions that mess with the body's temperature regulation, like multiple sclerosis or certain forms of epilepsy, often experience excessive, downright debilitating bouts of yawning. Similarly, prescription drugs that inadvertently raise brain temps, they'll cause a massive spike in yawns too. It even gives veterinarians a way to gauge hidden stress and anxiety levels in animals, since they can't exactly tell us when they're feeling overwhelmed. Which really leaves us with this final remarkable thought. For centuries, we just brushed off yawning as a simple sign of boredom or a desperate gulp for oxygen. We've even punished people for doing it in meetings or classrooms. But given what we now know about its complex role as a neural radiator, could monitoring the frequency and duration of our yawns become a key, non-invasive tool for diagnosing and treating severe neurological diseases down the line? It entirely reframes how we look at something we do every single day. Thank you so much for joining me on this explainer. And hey, the next time someone tells you it's rude to yawn, you can just tell them you're preventing your brain from overheating.